Good afternoon. In today's video, we're going to be taking a look at probably one of the most common questions that I get asked in teaching algebra, and also possibly one of the most common mistakes that I see as well. And that is, does the distributive property apply to exponents? Now, I'm going to be really blunt here. The answer is no.
Please, no! No!
No, absolutely not. A big, emphatic, red no.
No!
This absolutely does not apply. Do not apply it. Yeah, no, this does not work. Of course, I'm not going to just end it there. I do want to go into and break down why exactly this is the case and what is the difference between when we can distribute a coefficient versus why we can't distribute an exponent and what those two things really mean. But no, absolutely not. We cannot do this. But let's break this down. And I think the first place we want to start is what is the distributive property to begin with. And that's that for any real numbers, if you take the sum of two numbers, say b and c, and multiply it by a, that's going to be the same as multiplying by a by each of those individual numbers and then taking the sum. So a times the quantity b plus c, whatever that quantity is the same as the product of a and b plus the product of a and c. And I think the way you'll often see this written is something like this. We multiply the a by the b and multiply the a by the c, and that's what we call distributing. Now, I think it's important here to note that this isn't just some magical mathematical trick that we decide to apply. The reason that this is a property is because these two things will always be true. You can in fact do this in any order, and that's what I'd like to take a look at. Let's say we had an example like 5 plus the quantity 3 plus 8. Of course, we can do what's in parentheses first here, and we can say 5 times 3 plus 8 gives us 11, and then 5 times 11 is 55. But alternatively, we could also say, let's distribute that 5. And so if we have 5 times 3 plus 8, and we want to distribute that 5, we're going to multiply that by the 3 and multiply that by the 8. And so we have 5 times 3 plus 5 times 8. As we begin to simplify this, 5 times 3 becomes 15, 5 times 8 becomes 40, and 15 plus 40 is 55. And you'll notice this is exactly the same, right? These two are equal because either way that we do this, whether we add first or multiply first, it represents the same thing. And even with the notation that we use, this is represented really clearly if you think about what it really means. We're saying that, for example, we want to take a number like 5 and multiply it by a whole host of different things, right? Maybe we want to multiply that by 6 and by 4 and by 3 and by 8 and by 17 and by 12, and we wanted to multiply by all of those things. We could write it out this way. We're saying we want to multiply this 5 by 6, by 4, by 3, by 8, by 17, by 12, and that's what this really represents when we write it out this way. And so we can do that either by multiplying the 5 by each of those individually, or just by adding them all up first and then multiplying it by 5. Either way, it represents the same thing. Now, an exponent, on the other hand, is entirely different. An exponent, particularly in the case of a positive integer, represents repeated multiplication, at least in the case of positive integers. And now I'll note here that this is sort of what we'll rely on for the intuition here, just working with positive integers, but this rule and this notation will apply to all real numbers. And so what we mean when we say repeated multiplication is that 2 squared is equal to 4 because it literally represents 2 times 2. And 5 cubed is equal to 125 because it literally represents 5 times 5 times 5. Right? When we say repeated multiplication, this number in the exponent is telling us how many times we need to multiply this base by. Right? We have 2 2s, we have 3 5s. We can even do this with variables. If we said something like x to the 5th would represent x times x times x times x times x. Right? This is 5 times. And so this represents something totally different than just taking a product. It represents a repeated product. And so we say we are multiplying whatever that base is that many times. We multiply the base 2 twice, we multiply the base 5 3 times, we multiply the base of x 5 times, and that would still be the case if we had something like a plus b. And so if we say a plus b squared, what we're saying is whatever this number happens to be, the sum of a and b, whatever that quantity is, we need to multiply it by itself 2 times. A plus b times a plus b. Now, let's take a look at an example, because this is going to be really easy to show and verify that the idea of distributing doesn't really work here with exponents. So for example, let's say we had something like 2 plus 3 squared. There's a few different ways we can do this, but 2 plus 3 squared is 5 squared. If we want to do what's inside the parentheses first, right, follow our order of operations. 5 squared, or 25. We could also say it is 2 plus 3 times 2 plus 3. Right, and if we wanted to get really fancy here, we could start to FOIL, if you're familiar with that as well. Right, that's first, outer, inner, last. We've got 2 times 2 for the first, we've got 2 times 3 for the second, we've got 2 times 3 for the third, and we've got 3 times 3 for the last. This gives us 4 plus 6 plus 6 plus 9, or if we add all of these up, 25. Now, this might not be the easiest way to do it, of course, but this would still work, right? Because 2 plus 3 squared, 2 plus 3, the quantity, squared, represents repeated multiplication of 2 plus 3 twice. What will not work here, however, is to say something like 2 squared plus 3 squared. Right? This idea of distributing that exponent. That does not work in this case. And we'll see that because 2 squared plus 3 squared, well, 2 squared is equal to 4, 3 squared is equal to 9, and 4 plus 9 is 13, which is definitely not the same as 25. We can come up with a counterexample to this idea pretty quickly. And if you're ever in a test environment or whatever the case may be where you're wondering or second guessing yourself, just try nearly any example with some small numbers like 1 through 5. This will pretty much work out. These two are not the same, that you can't just distribute that 2 to each of these. Now you might be saying, but I swear there was a rule with exponents. If we had more than one thing in parentheses, we could apply the exponent to each. And you're right, but it is fundamentally different because here is the rule. So here is our exponent rule. This would be the product of a and b squared would be equal to a squared times b squared. And this would be true for any exponent actually. So we can just write a times b to the n is equal to a to the n times b to the n. And this is a true statement. This would always work. But this is fundamentally different than distribution. Now, the reason that this works, right, is let's say we took a times b to the third. Again, this exponent represents repeated multiplication. So we have to repeatedly multiply a times b times a times b times a times b 3 times. Now, since all of this here is multiplication, we can take advantage of 2 other properties of real numbers, the commutative property and the associative property. And basically what these tell us is that if the only thing we're doing is multiplying, we can do that multiplication in any order that we want. And so I can take this and rewrite it as A times B times A times B times A times B by getting rid of the parentheses. We don't need to separate those terms here if everything is multiplication. And then I can rearrange this further by multiplying all of the A's together first and all of the B's together second. And so we have A times A times A times B times B times B. Now, of course, A times A, because we're repeating multiplication of A 3 times, that's equal to A cubed. B times B, because we're repeating the multiplication of B 3 times, is equal to B cubed. And so we have A cubed times B cubed. A times B cubed is the same as A cubed times B cubed because it is all multiplication and of the associative and commutative properties. I know this one gets a lot of questions, and I know that many people will probably still make this mistake a few times before it finally starts to click, and that's okay. But try to keep this in mind and be careful and diligent as you're working through and making the distinction between these two things, because the distribution represents repeated addition, the exponents themselves represent repeated multiplication, and we have to handle those differently. But that's it for today's video. If you do have any other questions, please feel free to put them in the comments below. Thank you for watching and have a great rest of your day.